Assalamualaikum, my name is Nurul Azalina binti Muhaini, and today I would like to present our project dataset, which is satisfaction of airline passenger. For the introduction, we use this dataset because we want to predict which service qualities features that precisely affecting the airline passenger satisfaction, so that we can improve its quality services. Our dataset contains 129,880 instances and 23 attributes, which include satisfaction attribute as a class level. Besides, it contains mixing value and the mixture of the nominal and numeric type of data. So this is our numeric and nominal data. There are 18 attributes, which in numeric data, while the other 5 is nominal data. First of all, we will save our dataset collected from Kaggle under the file name of Airline Passenger Satisfaction Pre-Process, which we save it in a CSV or RAFF type of file. Then we will start doing the data cleaning using pre-processed dataset. We can see that in this dataset, there is 23 attributes, 129,880 instances, and also we will see the missing value and the type of data in every attribute. So there are two types of data, nominal and numeric data, that can be found in here, and we check every attribute whether it have a missing value or not. And we found that number 22, arrival delay in minutes attribute, have 393 missing values. So we will use the remove missing value filter under unsupervised and attributes. After filter is applied, we can see that the missing value turned to 0. Then we will start to reduce our data instances by using stratified removal under supervised instances, which we use 2 numfold to divide instances into 2 and remove half of it. Therefore, the remaining data have roughly equal for both class data. And why we want to reduce our data using this filter? Because there are machine limitations toward our dataset. Then we will remove flight distance and onboard service attributes directly from WCA without using any filter. Both attributes act as noises because both are weakly relevant to our objective data analysis, and we decided to remove the onboard service attribute because it has a similar term with the in-flight service attribute. After that, we check the outlier and the extreme values for this dataset using the interquartile range filter. After we apply, we can see that the yes label is represent the outlier, which is in the red color graph, and same goes to the extreme values attribute. We have to remove them using the remove with values filter under unsupervised instance. And after we apply, the value of the outlier and the extreme value will turn to 0. So now we can save our clean dataset under CSV or ARFF type of file. Okay, now we will prepare for the data transformation, which we will discretize the each attribute into 3 sections. So we use discretize filter under unsupervised attributes. We put attribute indices as 3 to represent each attribute's number, and the 3 bin as we want in the 3 section. Then we save this file under processing file in a CSV. After that, we will open the Excel to replace the old label in each customer class and satisfaction attribute into new labels. First, we will replace this unknown label in the age attribute into young, middle, and old labels. For the class customer, we will change the eco and the eco plus label into economy. For the satisfaction attributes, we will change neutral or dissatisfied label into 0, while the other satisfied label will change into 1. Then we will save and name the Excel into processing 2 dataset in a CSV type of file. Then we open back our WCA and open the file that we saved just now. We check all the changes in the each customer class and satisfaction attributes. We can see that the satisfaction attribute are in numeric type of data, but we want to change it in nominal, so we used numeric to nominal filter to change them. Then we will perform attribute construction, which we will use add expression filter under unsupervised attribute. We add new attribute by the expression of the summation of A19 attribute and A20 attribute, which we name it the new attribute as the total delay. Okay, now we can see the outcome of our dataset and set the satisfaction attribute as our class attribute. Then we save our process dataset under ARFF or CSV type of file. Then we normalize our dataset using normalized filter under unsupervised attribute, which in the scale of 0 to 1. Now we can see the outcome of the dataset, and what we can see is that the difference in the numeric values of the instances. Okay, now we can save our normalized dataset under ARFF or CSV type of file.
My name is Anu'Mila binti Abdulaziz, and I will explain about how we use J48 classifier on WCA. So first, we need to open the file that we want to use. For this case, we use process file. So after that, we click on the classify tab, then choose the classifier on the classifier option. So for this, we will use J48 classifier. And then, so for first test, we will run the cross-validation test with tenfold. And after confirming the class type, which is satisfaction, so we will start the test. So these are the results that we got for cross-validation with tenfold. So for correctly classified instances, we got 95.3232%, and for incorrectly classified instances, we got 4.6768%. For the second test, we will run a cross-validation with 20-fold, and we will start the process. These are the results for cross-validation test with 20-fold. So for correctly classified instances, we got 95.342%, and for incorrectly classified instances, we got 4.658%. After that, we run the third test, which is percentage split with 70% amount of testing data. So, and we click the start button to start the process. So these are the results for percentage split test with 70% amount of testing data. For correctly classified instances, we got 95.1338%, while for incorrectly classified instances, we got 4.8662%. The last test that we will run to the process file using J48 classifier is percentage split with 80% of testing data. So we will click the start button to run the process. These are the results for percentage split with 80% amount of testing data. For correctly classified instances, we got 95.219%, and for incorrectly classified instances, we got 4.781%. After running all the 4 tests to the process file, the best result output that we got is from cross-validation with 20 folds. So these are the 3 visualizer for cross-validation with 20 folds.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rajan Raiza Baby. So now I will continue for the process of random tree classification using Weka. So for the first step, after we have input the file of the dataset that we are going to use, so first we go to the classify column, and then we choose the classifier that we want to use, which is random tree. So now we are going to run the first test, which is cross-validation for equal to 10, and we make sure that the class label is satisfaction, and we run the test. So we get the result output, which is correctly classified instances is 93.3887%, and for the incorrectly classified instances is 6.6113%. So next we are going to do the second task, which is cross-validation for equal to 20, and then we make sure that the class label is satisfaction, and we run again the test. So we get the result of 93.5731% for correctly classified instances, and for the incorrectly classified instances we get 6.469%. And next for the third test, which is percentage split, 70% of the training data set. And we start the test. So we get the result of 93.3352% for the correctly classified instances. And for the incorrectly classified instances, we get 6.6648%. And lastly, for the last test, which is percentage split for 80% of the training data set. And start again the process. And we get the result of 93.2468%. And the incorrectly classified instances is 6.7532%. So now, after we have gotten the 4 results from the 4 tests that we have done earlier, 80% percentage split shows the best result among them all. So now, this is the 3 visualizer of the test that we have done. And this test consists of 9,657 trees.
Assalamualaikum, my name is Nur Ashifin binti Kamis Adin. Now I'm going to state the result for 10 folds for full dataset that use J48 classifier. Accuracy we have 95.3232%, incorrectly classified we have 4.6768%, true positive we have 31,669, true negative we have 24,158, false positive we have 1,745, false negative we have 994. Now the result for 20 folds. Accuracy we have 95.342%, incorrectly classified we have 4.658%, true positive we have 31,655, true negative we have 24,183, false positive we have 1,720, false negative we have 1,008. Now the result for percentage split of 70%. Accuracy we have 95.1338%, incorrectly classified we have 4.8662%, true positive we have 9446, true negative we have 7,269, false positive we have 494, false negative we have 361. Now the result percentage split for 80%. Accuracy we have 95.219%, incorrectly classified we have 4.781%, true positive we have 6,375, true negative we have 4,778, false positive we have 343, false negative we have 270. Now I'm going to state the result of 10 folds for full dataset that use random tree classifier. Okay, here the result. Accuracy, we have 93.3238%. Incorrectly classified, we have 6.6762%. True positive, we have 23,932. True negative, we have 30,724. False positive, we have 1,939. For false negative, we have 1,971. Now, the result for 20 false is accuracy, we have 93.4467%. Incorrectly classified, we have 6.5533%. True positive, we have 23,970. True negative, we have 30,758. False positive, we have 1,905. False negative, we have 1,933. Next, the result for percentage split of 70% for full dataset for using random tree classifier is accuracy, we have 93.0507%. Incorrectly classified, we have 6.9493%. True positive, we have 7,145. True negative, we have 92,704. False positive, we have 603. False negative, we have 618. Now, the result for percentage split for 80%. Accuracy, we have 93.5798%. Incorrectly classified, we have 6.4202%. True positive, we have 4,748. True negative, we have 6,213. False positive, we have 379. False negative, we have 373. Now, I'm going to state the result for 10 false for reduced dataset that use J48 classifier. Accuracy, we have 95.5452%. For incorrectly classified, we have 4.4548%. For true positive, we have 31,873. For true negative, we have 24,084. For false positive, we have 1,819. For false negative, we have 790. Now is the result for 20 false. For accuracy, we have 95.6374%. For incorrectly classified, we have 4.3626%. For true positive, we have 31,896. For true negative, we have 24,115. For false positive, we have 1,788. For false negative, we have 767. Alright, now the result for percentage split of 70% for reduced dataset for using J48 classifier. For result, we have accuracy 95.4468%. For incorrectly classified, we have 4.5532%. For true positive, we have 9,525. For true negative, we have 7,245. For false positive, we have 518. For false negative, we have 282. Now the result for percentage split for 80% is, for accuracy, we have 95.5007%. For incorrectly classified, we have 4.4993%. For true positive, we have 6,413. For true negative, we have 4,773. For false positive, we have 348. For false negative, we have 107. Now I'm going to state the result of 10 false for reduced dataset that use random tree classifier. For accuracy, we have 93.8838%. For incorrectly classified, we have 6.1162%. For true positive, we have 23,930. For true negative, we have 31,054. For false positive, we have 1,609. For false negative, we have 1,973. Now, the result for 20 false is, for accuracy, we have 93.7387%. For incorrectly classified, we have 6.2613%. For true positive, we have 23,941. For true negative, we have 30,958. For false positive, we have 1,705. For false negative, we have 1,962. Now the result for percentage split for 70% for reduced dataset for using random tree classifier. For accuracy, we have 93.3295%. For incorrectly classified, we have 6.6705%. For true positive, we have 7,180. For true negative, we have 9,218. For false positive, we have 589. For false negative, we have 583. Now the result for percentage split for 80% is, accuracy, we have 93.9469%. For incorrectly classified, we have 6.0531%. For true positive, we have 4,751. For true negative, we have 6,253. For false positive, we have 339. For false negative, we have 370. This is the comparison graph of J48 for full dataset versus reduced dataset. Alright, orange bar graph is reduced dataset, while blue bar graph is for full dataset. Okay, now I'm going to explain about the output result from this graph. Okay, first, the difference from the cross-validation with 20 false using dataset before being reduced is 0.2954%. Next, for percentage split for 70%, the difference from the dataset before reduction is 0.313%. Then, for percentage split for 80%, the difference from dataset before reduction is 0.2817%. And last, the accuracy increased by 0.22% for reduced dataset of 10 false if compared to the cross-validation with 10 false for the dataset before reduction. Alright, next graph. Next graph is about the comparison graph for random tree algorithm for full dataset versus reduced dataset. Alright, orange bar is for the reduced dataset, while blue bar is for the full dataset. Okay, now I'm going to state the output result from this graph. First, there is a slight increase of 0.1229% of result output for cross-validation 20 false in comparison to cross-validation of 10 fold for full dataset. Then, there is an increase of 0.5291% result output in 80% percentage split compared to 70% split for full dataset. After that, there is a slight decrease of 0.1451% for cross-validation 20 false compared to 10 fold for reduced dataset. And last, there is an increase of 0.6174% in 80% percentage split compared to 70% for reduced dataset.